Hi, I will talk to you in this first mini video about the first question included in the game. How does our planet work? Volcanoes. The first question is, what is the Pacific Ring of Fire? The Earth is formed from a series of rock layers, often compared to ones you can find in an egg or in an orange. Between the center of the planet at a depth of about 6,370 kilometers and the surface, the planet is composed of an internal core in orange here, an external core in yellow, a very thick mantle in red, and finally a very thin crust of a few tens of kilometers or less. Parts of the planet which are liquid are the external core in yellow and magmas which appear close to the surface and eventually will break through the surface to appear as lava. All the other parts of the planet are solid. That means the mantle, the crust, and the internal core. When we are talking about solids, there are two kinds of solids. Some solids are also fragile. The typical example is the crust. That means under high pressure, the crust will break and will create earthquakes. Other solids are called solids which are ductile. Typical example is the inferior part of the mantle. That means under pressure, the mantle will not break, but will deform over a long period of time. We are saying that it creeps. When we are going closer to the center of the Earth, the temperature and the pressure rise. It creates an excess of internal heat in the planet. And one of the consequences is that the Earth's mantle undergoes significant movements, which are called convective movements, or we speak of convective motion. That means the material is moving, creeping up and down in all this large region and volume, in fact. The mantle material is solid and ductile, and when it goes up to the surface, it could melt and becomes a magma, which is liquid. One typical way to do this type of trajectory is through the mantle plumes. Mantle plumes, which have the shape of a mushroom, consist of some material, mantle material, at the bottom of the mantle, which goes up to the surface and will eventually melt to create magma. At the time of the Earth's creation, 4.55 billion years ago, it's a big number, the Earth's surface was a large, hot, and liquid lava ocean. It slowly cooled down, and around 4.2 billion years ago, several water oceans started to form. Today, at the surface of the planet, we have several tectonic plates. At the moment, we can identify 7 major tectonic plates: the Eurasian plate, the Australian plate, the Pacific plate, the North American plate, the South American plate, the African plate, and the Antarctica plate. You can also observe that we have many smaller plates which are interspersed between the major ones. One particular interesting point of the plates is that they have limits, boundaries. And as you can see, I colored them in 3 different ways. The blue limits correspond to divergent boundaries. That means, for example here, on each side of the divergent boundary, the plates are moving away from each other. At a convergent limit or boundary, the 2 plates are confronting each other. And if you're near a transform boundary, the yellow ones here, you will see that the 2 plates are sliding near each other, but in opposite directions. The tectonic plates are solid and rigid. Now we can explain what it is. They act like rafts on the mountain. They go in different directions between the North Pole and the South Pole. They move at different speeds, and their number has changed over time during the Earth's history. Sometimes there were many of them on the globe, and at other times they were all together like a single supercontinent. The last one was called Pangaea and was created 250 million years ago. Most of the volcanic activity on Earth occurs along divergent boundaries. If you remember, the divergent boundaries are mostly found at the bottom of the sea, on the sea floor, and so such type of volcanic activity is very difficult to monitor. The second most active volcanic zone on the Earth is what we call the Ring of Fire, and it is a convergent boundary that encircles the Pacific Ocean. So here is again a series of plates, tectonic plates. You have a divergent boundary at the bottom of the sea, and you have the long convergent boundary encircling the Pacific Ocean, which is called the Pacific Ring of Fire. Here at the end of the first mini clip, you can find all the other clips necessary for the game on the blog. Have a nice day.